Hi students, in last class we discussed about atomic radius and its trend in periodic table. In this class we will discuss about ionization energy and also electron affinity. Ionization energy and its trend in modern periodic table. We will discuss about ionization energy and its trend in modern periodic table. The amount of energy required to remove an electron from the outermost cell of a neutral gaseous atom is called ionization energy. Already we learned that every atom contains nucleus and electrons revolve around the nucleus in a orbit, also called as cell. To remove an electron from outermost cell, we need some energy. The amount of energy required to remove electron from outermost cell of a neutral gaseous atom is called ionization energy. To remove an electron from outermost cell, we need energy. We call that energy as ionization energy. Here we can observe sodium atom. It contains one electron in third cell. Here third cell is the outermost cell. To remove that electron we need energy. That energy is the ionization energy of sodium atom. The energy required to remove the first electron is called first ionization energy. Energy required to remove the first electron is called first ionization energy, represented by IE1. The energy required to remove the second electron is called second ionization energy, represented by IE2, and so on. Here M is a neutral gaseous atom. To remove one electron from neutral gaseous atom, we need energy. IE1 is the first ionization energy. That energy is given to neutral gaseous atom. Then we can remove one electron from neutral gaseous atom. It will form M plus cation. Here IE1 is the first ionization energy. The energy required to remove an electron from unipositive ion of the element is called second ionization energy of that element, and so on. When one electron is removed from neutral gaseous atom, it will form unipositive ion. Now, the amount of energy required to remove an electron from unipositive ion of the element is called second ionization energy, and so on. Here M plus is the unipositive ion and IE2 is the second ionization energy. When energy is given to unipositive ion, we can remove another electron, second electron, then it will form M plus 2 cation. Here IE2 is the second ionization energy. Remember, IE1 is the first ionization energy. First ionization energy is greater than second ionization energy. Second ionization energy is greater than third ionization energy. Third ionization energy is greater than fourth ionization energy, and so on. When we remove one electron from neutral atom, it will form unipositive ion. When it forms unipositive ion, nuclear attraction will increase on the outer cell. So it is hard to remove electron from unipositive ion compared to neutral atom. As the number of electrons in the outer cell decreases, nuclear attraction will increases. So as the positive charge on the ion increases, it requires greater ionization energy. Ionization energy is expressed in kilojoules per mole. Units of the ionization energy is kilojoules per mole. It is expressed in kilojoule per mole. Ionization energy is also called the ionization potential. Ionization energy also called ionization potential. But when we use the term ionization potential, it is better to write the units electron volt per atom. If you use the term ionization potential, it is better to write units electron volt per atom. Now we will discuss about factors which influence the ionization energy, or factors which affects ionization energy. This is very important question. In that, first one is nuclear charge. As the nuclear charge increases, the attraction between nucleus and outer shell electrons increases. So it needs higher ionization energy. More the nuclear charge, more is the ionization energy. If the nuclear charge is less, we can easily remove the electrons. It requires lesser ionization energy. Second one is screening effect or shielding effect. More the cells with electrons between the nucleus and valency shell. As the number of cells between nucleus and valency shell increases, they act as screens and decrease nuclear attraction over valency electrons. This effect is called screening effect. More the screening effect, less the ionization energy. When screening effect is more, nuclear attraction on valency electrons will decreases. So, with less amount of the ionization energy, we can remove the valency electrons. Here, we can observe francium atom. Francium atom contains 6 inner cells. These 6 inner cells act as screens and they decrease nuclear attraction on 7th cell. So we can easily remove electron from 7th cell. More the inner cells, they act as screens and they decrease attraction on valency electrons. This is the screening effect or shielding effect. Third one is penetration power of the orbital. Penetration power of the orbitals. Orbitals belonging to same main shell have different piercing power or penetration power toward the nucleus. For example, different orbitals having different piercing power towards nucleus. For example, if we observe 4th cell, that is N cell, it contains 4s, 4p, 4d and 4f orbitals. 4s orbital having higher piercing power or penetrating power than 4p orbital, and 4p orbital having high piercing power than 4d orbital. 4d orbital having high piercing power than 4f orbital. So 4s orbital having high piercing power and 4f orbital having low piercing power. 4f orbital having low piercing power. So we can easily remove electrons from 4f orbital compared to 4s orbital. In beryllium, beryllium atomic number 4, electronic configuration 1s2, 2s2. And boron, boron atomic number 5, electronic configuration 1s2, 2s2, 2p1. In beryllium, valency electrons are present in 2s orbital. In boron, valency electron is present in 2p orbital. The element beryllium has less ionization energy due to less penetration power of 2p orbital compared to 2s orbital. In boron, valency electrons are present in 2p orbital. So we can easily remove electrons from boron compared to beryllium, because in beryllium valence electrons are present in 2s orbital. 2s orbital having high penetration power compared to 2p orbital. We will discuss about fourth factor, that is stable configuration. stable electronic configuration. If a atom contain half-filled or completely filled configuration, it is stable. If a atom contain half-filled configuration or completely filled configuration, it is stable. When it is stable, it needs greater ionization energy. Stable atom needs greater ionization energy to remove electron from outermost cell. For example, nitrogen. Nitrogen atomic number 7, electronic configuration 1s2, 2s2, 2p3. It contains half-filled configuration. Oxygen. Oxygen atomic number 8, electronic configuration 1s2, 2s2, 2p4. Compared to oxygen, nitrogen having half-filled configuration, it requires greater ionization energy. When atom contain half-filled configuration, it is stable, it requires higher ionization energy. And we will see another example, neon. Neon electronic configuration is 1s2, 2s2, 2p6. It contains completely filled configuration. Fluorine. Fluorine electronic configuration is 1s2, 2s2, 2p5. So compared to fluorine, neon having completely filled configuration, so it needs greater ionization energy. Ionization energy of nitrogen is greater than oxygen. Ionization energy of neon is greater than fluorine. Fifth one is the atomic radius. More the atomic radius, less is the ionization energy. As the atomic radius increases, nuclear attraction over valency cells decreases. So we can easily remove the electrons. More the atomic radius, less is the ionization energy. Atomic radius and ionization energy are inverse variation. As the atomic radius increases, ionization energy decreases. For example, ionization energy of fluorine is greater than iodine. Fluorine, iodine, they belongs to 7th A group. From fluorine to iodine, atomic radius increases, so ionization energy decreases. Therefore, ionization energy of fluorine is greater than that of iodine. Fluorine and iodine belongs to 7th A group. From fluorine to iodine, atomic radius increases, so ionization energy decreases. Fluorine having greater ionization energy than iodine. Similarly, sodium having more ionization energy than cesium. Sodium, cesium belongs to 1st A group. From sodium to cesium, atomic radius increases, ionization energy decreases. That's why sodium having greater ionization energy than cesium. Ionization energy decreases as we go down in a group and generally increases from left to right in a period. In a group, from top to bottom, atomic radius increases, so ionization energy decreases. If we go from bottom to top, ionization energy increases. And in a period from left to right, atomic radius decreases, so ionization energy increases. In a group from top to bottom, ionization energy decreases. In a period from left to right, ionization energy increases. Now we will discuss about electron affinity. An atom is able to gain an electron only when the electron outside the atom is attracted by its nucleus. When another atom comes close to the given atom, the electrons in the second atom will attracted by the nucleus of the first atom. This attraction involves the liberation of energy. When there is a attraction between nucleus of one atom and electrons of the other atom, there is a liberation of energy. This energy is the electron affinity. Now we will see the definition for electron affinity. The electron affinity of an element is defined as the energy liberated when an electron is added to neutral gaseous atom. When an electron is added to neutral gaseous atom, there is a liberation of energy. That energy is called electron affinity. Here M is the neutral gaseous atom. When an electron is added to neutral gaseous atom, it will form anion and it releases some amount of the energy. That energy is the electron affinity. Here A is the electron affinity. Electron affinity of element is also called electron gain enthalpy of that element. Electron affinity also called electron gain enthalpy. Electron gain enthalpy values decreases as we go down in a group. Similar to ionization energy, electron gain enthalpy values also decreases as we go down from top to bottom in a group and increases along a period from left to right. In a period from left to right, ionization energy values increases. Similarly, electron gain enthalpy also increases. Metals have very low electron gain enthalpy values and alkaline earth metals have even positive values. Metals having low electron affinity values. Alkaline earth metals having even positive values. Here positive sign indicates they will absorb energy. Negative sign indicates they will release energy. All the factors which influence the ionization energy would also influence the electron gain enthalpy. The factors which influence the ionization energy also influence the electron gain enthalpy or electron affinity. Here this is a question which is given in public examination March 2017. Explain any 4 factors which influence the electron affinity or electron gain enthalpy. So we have to write same factors which are given for ionization potential. Nuclear charge, screening or shielding effect, stable electronic configuration, penetration power of the orbitals, atomic radius. Same factors we have to write for electron affinity.